Hey folks, it's Friday, so that means we're going to get to do a little bit of a live broadcast. It's kind of fun. Um, so every week we're going to do something from whatever came up during the week. This week, folks have figured out how to overcomplicate machine learning. So we're going to talk a lot about that. Not sure how many, but we've talked to quite a number of folks about machine learning, and they get stuck. They all kind of get stuck in the same spot. And I think it's mostly a result of you got a bunch of scientists trying to figure, they're good at the science part, but they're not very good at the engineering part. And we're going to try and clarify some of that. And then, when you get the engineers who are trying to work with the scientists, they look at that and see machine learning and think voodoo magic. And I think we're just going to try and clarify a little bit that it's just not as complicated as folks seem to think. There's this big mystery or whatever about machine learning that gets folks to think that machine learning is very complicated and very hard. It really just isn't. It's very similar to regular software, and it's crazy. Folks get so scared of it, and I drew a diagram. So let's try to look at this. It's very straightforward stuff here, right? Like this is what putting machine learning in production should look like. And I've got a code repo. I'll see if I can find that GitHub that I've got on this, but this is it. It's classic engineering 101 stuff. Like this, everybody does this, or if you don't do this, you should be doing this. Right, so you've got some scientists, and they're making some machine learning models. They're doing their thing. It's all back here. It's like a dev process, just like the devs do. The devs have their own environments. They're writing code, like doing it on their local machine, share it with their other buddy on their local machine. They're going to push it into Git, or they're going to check it into their source control of choice. Same thing with machine learning models. Like they're going to go and they're going to use their big fancy clusters. They're going to run a bunch of training things. They're going to test it, be like, this one looks pretty good. Let's check that one in. And that's it. And then you have a continuous integration process that kicks off because you have a piece of code that takes the machine learning model and uses it and acts inside of whatever production system. It could be an embedded device. It could be a web application. It could be anything. We could put it directly into a processing stream. And the CI process just takes these two assets, it goes whoop, and shoves them together, and then runs your unit tests with those two assets together and deploys it to a development environment. So if you're doing, you should like deployment rings. This is classic engineering. This is where the scientists usually get confused. The scientists get confused because they're used to making machine learning models, getting awesome performance characteristics. The car is going to drive all by itself, and like this concept of a CI process and deployment rings and like approval gates and all that kind of stuff is usually fairly foreign. And then the engineers, they go look at the process that it takes to build one of these machine learning models, and they look kind of behind the aspect that this is an asset that's just like a binary file sort of situation that they just load, and they see all the big fancy clusters with the GPUs and like the numbers and the metrics and things they don't get. They're like, whoa, what do we got to do about this? You do what you always do with it. In video games, it wasn't complicated. Artists went and made a big fancy art file, and you took that art file and you combined it with your code file, and you stuck it in your CI process and deployed it to dev. We're doing the same thing. It's nothing new here. So I wanted to make sure we clarified that. Now, there's a bunch of software in place now that makes this a little bit more complicated maybe. So like, they've got all these collaborative development environments, and there's things that are putting more power into the hands of the scientists, allowing them to build, deploy, manage, maintain their own models, and that's supposed to make things easier for them. They get a CLI and an SDK, but still you just use those tools and implement the same process, right? So if you're using like the Azure Machine Learning Workspace, it has a CLI for deploy model. It has a CLI for register model. So register model, right? Now I got my model. It's in my repository. Repository doesn't have to be Git. It's just a repository. Inference code. You're going to pull that in from there. And then combine it together in that CLI deploy step. That could totally be an Azure DevOps step or a GitHub action. You're going to go to your development environment. Let's just pretend that this is a containerized solution and it's going to an Azure container instance. It's going to go to the development environment. You're going to test it there. Then you're going to, it's mostly for the devs at that point, right? Then we're going to go over to the QA environment, this guy right here. In the QA environment, you're letting more people test it. You might even do a little bit of a blue-green between prod and QA, maybe. I don't know. Some folks could. And then you might split the traffic over more and then promote it and do a full automated deployment to QA, or to prod, I'm sorry. And that's it. That's machine learning 101, DevOps. Folks make it more complicated than it really should be. And you're doing exactly the same thing that you always do, and just, you know, there's no real magic or mystery here. Just you know, the scientists kind of see the engineering side, and that's foreign to them, and the engineers see the science side, and that's kind of foreign to them. But the scientists are going to go do the science step, and then you just kind of plug it into your regular engineering process for delivery of all software systems that anybody's ever delivered for at least the past 10 years. Like, you should be deploying software like this. So that's it for today, and we'll see you next Friday.